Welcome guys to this lecture. So in the last lecture we studied the foundations of the statistics where we studied about what is statistics, what are the different type of statistics like descriptive, inferential. Then we studied about the types of data where we studied about the qualitative data, quantitative data, categorical data, numerical data. Then we studied about the scales of measurement where we studied about nominal, ordinal, interval ratio, and then we studied about the population versus sample data. So these are the fundamentals of statistics. So in from today onwards we will focus mostly on the descriptive statistics part. In that we'll going to study about the measure of central tendency. So we'll start these concepts. So what is the measure of central tendency? Measure of central tendency is the is nothing but the it's nothing but the concept used to it is the concept used to find the center value. Concept used to concept that deals with the center value in the dataset. Center value in data. Okay, so why this center value is important in the data? See, let's say that you are having some records. Let's say you are having A, B, C records. Here you are having 90, but you don't have the B value, and C you have, let's say, 80 value. Okay, but the problem is since you are having less amount of data you cannot skip this B. So for this what you will do, if you use the measure of central tendency, the you can able to predict this value of B. Let's say how you can able to do, let's say we'll take the average 890 plus 80 by 2, and here the value will get us 85, and this 85 will be added in this place. So for achieving this thing you should know the concept of central tendency. So to represent the center in the data set where most of the data is stored, like if you see the data, like in the center part of data majority of the data will be stored. So that's why it's important for us to know more about the central value. So there are three matrices that we use when we say about measures of central tendency. One is mean, one is median, one is mode. What is mean? Mean is nothing but the sum of all observation divided by number of observation. So here I'll write the formula also. Mean, which is also written as x bar, this can be written as sum of n observations. Sum of observation versus number of observations. Total number of observations. So like let's say if we have like this is about the mean. So what is median? Median is nothing but the middle value of the data. And for to achieve median, your data should always be sorted either in ascending manner or descending manner, but the data should be sorted. Mode means what? The mostly occurred value in the data is called as mode. Generally we use mode for categorical data. In the last lecture I taught you about what is categorical data. Okay, categorical data. So first we'll understand what is the mean, how to calculate mean. Mean is you can also represent the mean as summation of x, which is nothing but sum of all values divided by total number of observations as n. You can write this also. So mean, to calculate the mean we are using this particular formula. X means sum of values, n means number of observations. Let's say we take this example. Let's say this is the particular data. So to calculate the mean, you will take the sum of all these things, and how many and total numbers are there? 1, 2, 3, 4, 5. That's why you divide it with 5. So you will get the mean as 70. But there is one challenge with mean. The challenge with mean is it is sensitive to outliers. Sensitive to outlier. Sensitive to outlier. To outliers. Very sensitive. I'll take one example for this. Let's say you are having the data as 50, 60, 70, 80, and instead of 90 we are having, let's say, 300. How much? 300. Now if you take the sum of all of these things, so 50 plus 60, 110 plus 70, 180, 260 plus 300, 560 divided by 5. If you take 560 divided by 5, you will get 1 1 means 1 0 means 1 1 2. You will get 1 1 2. So so now you see, you compare both the means. 70 is there, 112 is there, so there is heavy gap in the mean. So that's why this is there, because this 300 is the extreme outside value. So this 300 is nothing but the outlier. So that's why this particular mean is sensitive to the outliers. So that's why whenever the outliers are there in the data set, we won't be using the mean. Instead, we will use the median. So for doing median, first you should always arrange the data in the sorting manner, either in ascending or descending. Let's say I'll take one example. You are having, let's say, 50, 40, and 60, let's say. You cannot directly find median like this. First you have to sort this data. So here let's say we'll sort in the ascending manner: 40, 50, 60. Here we will sort in the ascending order. We'll going to solve. So now if you so now this is the first step that you have to do. Second step is you have to identify the middle value. Now when your n is odd, n means number of observations are odd, your center value will be the mean. Center value will be the median. But when n is even, you will take the average of middle two numbers. Average of middle two numbers. Middle two numbers. Now so now in this case example, here you are having the data as 10, 20, 30, 40, 50. How many, what is the n? N is 5 here. So since n is 5 here and the data is in sorted manner, so 30 will be the median. So this is true when it is odd. But one thing here, if let's say you are having the data as 10, 20, 30, 40, 10, 20, 30, 40. So your median will be what? See here the data is sorted, okay. Median will be 20 plus 30 by 2. That is 25, the centermost value. So when this comes when n is even. Okay. See, the best part of using the median is it is not sensitive to outlier. How it is not sensitive to outlier? I will take one example to explain why median is not sensitive to outlier. Now let's say here I am having the value as 10, 20, 30, 40 and 300. Still your median is how much? Median is how much? 30. If you take this example also, median is 30. So that's why though it is an outlier, but your median will never be affected by the outlier. So that's why whenever outlier comes, always use median instead of mean. So this is the concept of median. I hope you understand. So what is the mode? Mode means most occurred value. Most occurs. Okay. So now let's say I will take one data. Like let's say we will take this data only. See in this data, which number is maximally repeated? So here mode is 3. Why mode is 3? Because here two particular places 3 is there. So 3 is maximum repeated. So how many modes are there? Only this one mode is there. That's why it is called as unimodal. Since it has only one mode, it is called as unimodal. When let's say if you are having two modes, let's say if I take the example of data as 2233, 2233. If you take mode now, you will get 2 comma 3, 2 comma 3. So here how many modes are there? Two modes are there. That's why it is bimodal. Similarly, if more than two modes come, it is called as multimodal. So and this mode we will use for the categorical data. Categorical data. We won't be using it for numerical data. So whenever we deal with the analysis part, if the data doesn't have any categories, then go with the median or mean, provided check outlier first. But if you are dealing with the categorical data, always go with the mode. Now comparing these three models, mean uses all the data points but it is sensitive to outlier, but it is mostly used if the outliers are not there. If no outlier there, no outliers. Similarly, for median, it is resistant to outliers, means it is very strong when outliers are also there. Best for skewed data. Skewed data is nothing but the data which has outliers present. So this is best for those cases where data is skewed. The third one is positional measure. It is also very good in terms of positional measures also. Third thing is mode. It shows most common value, most repeated value, most repeated, most occurred, yeah, most repeated. Okay, most repeated. It works with the categorical data, can have multiple values as well, because here we studied about unimodal, bimodal, multimodal. It so that's why you can apply multiple values. So what are the real world applications of measures of central tendency in education sector? To find the average marks of students across classes and subjects, you can use this measures of central tendency. In business sector, you can use to calculate the average sales of particular month or year, that you can calculate using businesses. To find the in economic sector, to find the average gdp a person is earning per year, that you can calculate using economics. In healthcare, to find the average age, weight, blood pressure, or 3 months average of sugar calculation, these all things can be done in the healthcare sector. Then in the government sector, to study about the policies like income, how much a person is earning per month, what is the literacy rate of the country. So this all can be calculated by using the measures of central tendencies. In sports, like what are the average scores scored in the ODIs, how much what is the average that a batsman is scoring, that you can calculate using this measures of central tendency. So these things you can do using the measures. And in research also, you can compare the data set and analyze which data is best for your particular project, that you can do. So from this, one important conclusion we can make: when data is normal, no outliers present, use mean. If outliers present, use median. If you are working with categorical data, use mode. So I hope you understood this concept. Now we will going to implement this concept in our VS Code. So here I will open my VS Code here. So here I'll type VS Code. VS Code here, not this one. What? Where is VS Code here? I just want to open VS Code. VS Code. Okay, Visual Studio Code. It came here. Now here in this, I will go to my open folder. So in this YouTube, I written the folder as codes. There we'll going to do these things. So here I write measures of central tendency. Measures of central tendency dot py. So now in this is to do measures of central tendency, we have two approaches. Either you can use NumPy or use the stats model. See, using stats is very useful as this method is very easy. So to use measures of central tendency, we'll be using the stats approach. So for this, you have to go to terminal, go to new terminal. So now in this, you have to first install the statistics module. So pip install statistics, it's already satisfied, means it is already installed in my system. So now import statistics, as we are giving lis as stats. So now you have to give the data. So in the data I'll give 10, 20, 30, 40, 50, 60, 70, 80, 80, 90, 90, 100. So total how many are there? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So even are there. Okay. So now here if I want to go and print my data, I'll just type the data and here I will write data. So now you have to apply the measures of central tendency. Central tendency. So now here I will create one variable called mean. So in the mean what I will write, I will just write stats dot mean function I will write. In this I will pass data. When I write median, here I will write stats dot median. Here I write data. See, to calculate mode, we are having two approaches. We are having the two approaches. Okay. If you want to print only one mode, if you want to print only one mode, print only one mode, use stats.mode function. Okay, use stats.mode. But if you want to print all the modes, print all the modes, like it might be multi-mode or it might be bimodal, like here we in the PDF we discussed, right? You have unimodal, bimodal and all. For this you will be using stats.multimode. Okay, so this is how you can able to do it. Now first I will create the mode. Okay, in this stats dot mode, so in this mode I will pass the data and here I will again pass. Now here I want multi-mode to print, because see here in this data you are having 280s and 290s. So what should be your mode? It should be what I can say, 280s 290s means bimodal it should be. So stats dot mode, sorry, stats dot multi-mode. Here I will write data. Now I will print mean. Mean. So here I'll write, here I'll write mean, here print median. Here I will write median. Third one is print. If I want to print only single mode, then here I'll write mode. If I want to print multiple mode, here I will write multi mode. So now what I will do, I have to im- in im- run this code. So I'll just write python measures or pi. See, now you can see here data has been displayed because here we printed the data first, then mean value is came 60. How mean value came? If you add all of this, divide by 12, you will get the mean as 60. Median is 65. Why median is 65? Because the it is an even data. So what it is doing, 60 plus 70 by 2, so 65 it is giving. Single mode means what? Like the starting first mode which is been found, it will show the first mode. But if you want to print all the modes in the data set, you have to use this multi-mode and you will get the multi-mode value. So I hope you understood the implementation of measures of central tendency. So it is very easy, right? So you just have to focus on the implementation and need to understand the theory. So that's it guys, I hope you understood this lecture. In the next lecture we will study about the measures of spread, we will going to study, or measures of dispersion we'll going to study. That is very important. So thank you guys, please do like, share and subscribe.